So today we're going to talk about quadratic and square root inverse functions. We've talked about inverse before. Okay, so first thing you have to know is what a quadratic function looks like. What shape is a quadratic function? A U, thank you. Quadratic function is shaped like a U. What shape is a square root function? Close, it's a half of a parabola, so it's only half of it, okay? You have to understand what each of these look like. We are taking what we have done with both of these graphs and transformations and putting them together. So we have two rules for finding an inverse. Does anybody remember what the inverse means you're supposed to do? You have to do something. Oh, you're just yawning. It means you have to switch two things. Do you remember what you have to switch? What? It's going to be a long class period. Y'all don't know any of these answers. You have to switch your X and Y. This isn't from yesterday. This is from first semester and was on your final. And if I switch X and Y, what else switches? What else has to do with X and Y? No. Lord have mercy. Domain and range. So if I switch X and Y, I switch the domain and range. The second thing that happens when I have an inverse is it reflects over the line y equals x. Reflects over the line y equals x. Okay? So these are the two rules I have to remember when I'm talking about inverse. The minute I see inverse, I should be thinking switch X and Y, switch X and Y. That's what I should think first, okay? All right, so we are not going to do numbers 1, 2, and 3. We're not gonna do those. We're gonna flip over to the second page and we're gonna start on number 4. We're just gonna jump on in there, okay? So here's what I need to know. This original function is what type of graph? A square root, okay? So this is a square root. I'm gonna write SR for square root. You should be using your regular pencil. And a square root looks like half of a parabola. And if you draw this on every problem, it makes it a lot easier. If I start as a square root, the inverse has to be a quadratic. That's its only choice. It has to be a quadratic. So if I start as a square root, my inverse is a quadratic. Here's the thing. Your inverse has to look exactly like the original. Do these graphs look the same? No. So how do I change my inverse? What could I do to a whole parabola to make it look like a square root function? What's something you think I could do? I could cut it in half or split it, okay? So I will cut the negative side of my parabola off. So now I have half a parabola and half a parabola. This right here is called a domain restriction. Domain restriction. When I restrict something, I am stopping it. So I'm not drawing an entire graph, I'm just drawing half my graph. A domain restriction. Those are two important words you're going to have to know, okay? So let's go to my original function. I have a square root. I need my parent points. What are my parent points for a square root function? It starts with 0. What's next? 1. What's next? No. 4. 9. If I take the square root, what's the square root of 0? Square root of 1, square root of 4, and square root of 9. Now, in order to graph the function it gives me, I have to know my transformations. What does a +3 on the inside mean? It moved left 3. And what else did it move? Up 1. So we need to go put those on my table. Left 3 is in X direction. I'm going to subtract 3. And up 1 is a Y direction. This is all review. You should know how to do this. 1 minus 3, 4 minus 3, and 9 minus 3. Then I'm going to add 1 to my Y side. So I'll have 1, 2, 3, and 4. Which points go on my graph? The furthest ones out. So graph these and then find your domain and range. So everybody should be graphing and finding your domain and range. Okay. So no part of that graphing is new. That we should all know how to do. And if not, we need to really practice it because it's not going away. So when I graph my original function, I have a domain of -3 to infinity, and I have a range of 1 to infinity. Do we agree? Okay. Now I'm going to take my colored pencil. You should have your colored pencil. If you're online, you need to change colors. And now I'm going to graph my inverse. If my original had a point of -3, 1, what is the inverse of that point? 1, -3. So my first point's going to be 1, -3. Instead of -2, 2, the inverse is 2, -2. Instead of 1, 3, the inverse is 3, 1. And instead of 6, 4, the inverse is 4, 6. Okay? That's what it means to be inverse, to switch, right? That's what we said over here. Switch your X and Y. So I just switch what X and Y are, never the negatives, just the entire number. Okay? All right, so take these points and put them on your graph. 1, -3, 2, -2, and so forth. You need a starting point and you need an arrow, colored pencil. You should be using your colored pencil for the inverse. That way you can tell the difference. Graph got a little crooked there at the end, huh? What is the domain of my inverse function? Anybody? 1 to infinity, very good. What's the range of my inverse function? -3 to infinity. So just like we said on the front side, since my X and Y switch, look what happened to my domain and range. They switch, okay? So domain and range have to switch. Now, infinity, it's just not close. All right, so 2 things left. The last thing you need to do is take your pencil and draw that line Y. Excuse me, Y equals X. That's a diagonal line through the origin, like 1, 1, 2, 2, 3, 3. So we're going to take a diagonal line through the origin to graph the line Y equals X. okay? Why is that line important? Because if you connect your dots, so look up here, if I connect my orange dot and my blue dot, they should be the same distance away. If they're not, you did something terribly wrong. So my orange dot is 2 diagonal boxes away, and my blue dot is 2 diagonal boxes away. If you fold your paper on this line, if you fold it perfectly and you hold it up to the light, what do you think should happen to those 2 lines? They should be perfectly on top of each other because it folds over that line, okay? Last problem or last question, then we're gonna go to one more example. Is the inverse a function? All I'm looking at is my blue line. Is it a function? This is called a vertical line test, meaning on my inverse, so just looking at the blue, if I have a vertical line, how many times does that blue graph touch my vertical line? Once. What if I move it here? How many times does it touch it? Once. So if I move my line anywhere and it only touches it once, the answer is yes, it is a function. If you touch it more than once, the answer is no. Okay, we're gonna go do one more problem. So let's go do number 5. Number 5, what type of graph does number 5 start as? A quadratic. I'm gonna write a Q and I'm gonna draw a parabola. If I start as a quadratic, what do I have to turn into? A square root, and a square root is half of a parabola. How do I make my square root look like my original? What can I do to it? I can add another half. This right here is the positive half, and I can add a negative half. Because as we talked about yesterday, when you take the square root, you get a positive and a negative number, okay? So now my graphs look like they are the same shape. So let's start with my original. A quadratic, I need parent points. My parent points are -2, -1, 0, 1, 2. And if I have x squared, what are my y values? What is -2 squared? 4. What's -1 squared? 0 squared, 1 squared, and 2 squared. So let's put on my transformations. What does a +2 on the inside mean? It went left 2. What does a +1 on the outside mean? Up 1, thank you. Put those on your table. So all we're doing is putting our transformations on our table. And then what points do I graph? The ones that are on the outside. The ones that are on the outside. So graph those and get your domain and range. Graph those points and get your domain and your range. When I get my original points or my starting points, how do I find my inverse points? What am I going to do to these? Anybody? Flip them. I'm going to flip them. So instead of -4, 5, I have 5, -4. When you do your inverse, you should be using your colored pencil. When you do your inverse, make sure you're using your colored pencil, please. What you stuck on? Did you flip your points? Did you put those on your graph? Put those on your graph. Where's your colored pencil? Well, come on, kid. My domain for my inverse, and get your range for your inverse. Okay. Don't forget 2 important things. You need that diagonal line drawn. Because it's supposed to flip over. Y equals X. It has to flip over that line. If it doesn't, ooh, Nelly, we messed up somewhere. Okay. So my vertical line test is the inverse. My blue graph, is it a function? If I hold a straight line up and down, how many times does the blue touch that straight line? 2 times. So is it a function? No. Okay, so if you say any number besides 1, the answer is no. It is not a function. Did this graph need any type of restriction? Did I have to stop you from graphing something? So I'd make sure you know that. This had no domain restriction. There's no domain restriction. Okay. So here's what we're gonna do for the next 30 minutes. I want you to finish number 6. When you finish number 6 and either Mr. Mattel or I check it, then you will get a paper that has 4 more graphs on it. When you finish those, you are done for the day, okay? So everybody should be working on number 6. If you have questions, I need you asking, and I'll put the answers up there in just a minute. If you are not drawing your little Q and SR, I think you're silly. All right, here's my answers to number 6. If it is correct, then I'll come check it and you can get your second set of problems. If you are on Zoom, your second set of problems is in the assignment worksheet number 2. Assignment worksheet number 2. Y'all, if all you're doing is copy, and I promise it's not going to be good on Monday, so make sure you're asking questions. You won't know how to do Very good. Does this need a domain restriction? So your inverse has to be exactly like the original. Does this look like it? So what you have to do is graph. You have to cut it in half. So if you tell me cut it in half, that is a restriction or stopping. So does this graph need a domain restriction?
I'll put this on your table. So in your bag.
Who else needs a new paper? Yes, and it needs a restriction. Very good. Very good. You won't have to do this. Just do that one thing blank. Everything else you don't have to do. Does your graph need a domain restriction? Is that one line? What did it start at? What kind of graph did we start at? A square root, which looks like this. What does it turn into? Quadratic, which looks like this. Do those look exactly the same? Thank you, Garcia. So, this, how do I turn this into that? What am I going to have to do? I'm going to have to cut it, which means I need a domain restriction. And that's if I were you, that took all of about 10 seconds to do. I write that on every problem, right? You will still have to do the equation. That's the only blank you have to have done.
So how do you know if it's in group?
So is the inverse. So is your green a function? If I take a straight line up and down, it can only touch it once, touch it once, touch it once. See this one right here? How many times does it touch it? So that's done. Very good. Okay. How do you make this graph look like this one? What are you gonna have to do? You're gonna have to cut it. So you have to make sure you know that, because when you cut it, that's called a restriction. You have that somewhere on your paper, okay? All right, here's the second one. You won't know how to do this, so just skip that one line today. You need your paper? Y'all killing me without putting a restriction, yes or no. I need that on number 6. First of all, you can't go from a square root to a square root, right? Okay, square root looks like this. Quadratic looks like this. How do I make my inverse look like a square root? What am I going to do?
The function.
If I have something whole and I need to make it look like a piece of it, what can I do to this graph? Cut it to the right, not or something. That's what we're gonna do. We're gonna cut it in half. When I cut something, when I cut something in half, that's called a domain. We check our.
That's what I'm doing.
It's easier if you wrote it instead of me. Okay, you have to know that. So you don't have to. Okay, so on this paper, I want you to draw these like we did right here on every single problem. Okay, you won't know how to do this. That's what you want to explain, okay? How are we doing over here? Nope, you're gonna do this page when you're done. So I need to know, does this have a domain restriction? So if I started as a square root and I end as a quadratic, how do I make my inverse look like my original? What am I going to have to do? I have something that's whole and I need to make it look like this. What can I do to that whole graph? No, you can't change the original, you can only change the inverse. How are you gonna do that inverse? Get rid of half of it, all of the negative, right? So if I get rid of something, what is that called? Down, okay? Okay, my example. You won't know where my blue dots are, you will leave those lines blank, you don't know how to do this. Okay, what we got? First of all, you need some arrows on your graph. I don't know if this graph goes this way or if this graph goes this way. Okay, so you have errors. Same thing. Quadratic. How do I make this look like the original? inverse a function. That's your vertical line. So you gotta hold something. I don't care about the inverse of your 3, right? So hold something straight up and down. How many times does that go up and line? Say once. Then what is that? Yeah. Right? You won't know how to do these 2 things, but everything else will have to do that. Blank right now. My Zoomers, you should be on this page, number 2, when you are finished. The only thing you don't know how to do is the inverse equation. That's the only thing that should be blank. Did not realize I was